Welcome to The Explainer. Today, we're tackling what is easily one of the most transformative concepts in the world of artificial intelligence right now. If you've been following the AI space, you already know that large language models are incredibly powerful. But you also know they have some pretty serious limitations when it comes to actually trusting them with critical, real-world tasks. Well, we're decoding the ultimate tool for reliable AI today: Retrieval-Augmented Generation, or RAG for short. We're going to break down exactly how it works, why it's basically the silver bullet for AI accuracy, and how developers are engineering these systems to be literally lightning fast. Okay, let's dive into this. Here's our roadmap for the explainer. First up, we're decoding RAG basics. Second, curing AI hallucinations. And third, reducing system latency. Section 1. Decoding RAG basics. Understanding the R, the A, and the G. So while RAG sounds highly technical, the underlying logic is wonderfully straightforward. Think of the flow of data as a really logical three-step journey. Step 1 is the R, retrieval. When a user asks a question, the system doesn't just take a wild guess. Instead, it actively searches and fetches the most relevant information from trusted, external knowledge sources. It actually goes out and finds the facts. Step 2 is the A, augmented. The system takes that user's query along with a few instructions and packs that retrieved factual context right into the prompt. It literally augments the question with the exact facts needed to answer it. And finally, step 3 is the G, generation. The generator LLM processes that highly detailed, fact-packed prompt to generate a final response. It's essentially reading the context you just handed it and giving you a coherent, perfectly tailored answer. Let's lock this into our minds. RAG stands for Retrieval-Augmented Generation. Instead of asking an AI to take a closed-book test relying purely on its internal memory, RAG turns the whole thing into an open-book test. You retrieve the right textbook page, you augment the test question with that page, and then you ask the AI to generate the answer. This specific data flow is the absolute bedrock of building AI applications that actually know what they're talking about right now in the present moment. Moving on to Section 2, curing AI hallucinations, why RAG is essential. Without that open look capability we just talked about, we slam right into the biggest roadblock in generative AI today, the hallucination. A hallucinated response is an answer that sounds completely plausible, highly confident, grammatically perfect, and yet is completely confidently wrong. Honestly, it's amazing how an AI can lie with such conviction. This happens because a standalone LLM only knows what it learned from its original training corpus. And that training corpus, it's static. It can easily be completely out of date or just entirely incomplete for really specific or recent topics. If the model doesn't know the answer, it's literally designed to predict the next best word anyway, which is exactly what leads to those fabrications. And this brilliantly illustrates the night and day difference in system architecture. Without RAG, you're flying blind, relying solely on an out-of-date, incomplete training corpus, which leaves the system incredibly prone to making things up. But when you introduce RAG, you introduce external retrieval. You're pulling from factual, up-to-date sources, making the final output highly accurate. You're no longer relying on the AI's frozen-in-time memory. You are relying on the actual, live data you feed it at the exact moment the query is made. So, what does this all mean? The crucial point is this. By combining retrieval with generation, you ensure that answers are contextually relevant, completely factual, and you significantly enhance the overall output reliability. This is exactly how developers build trust. Think about it. When a user asks a critical business question, or a medical question, or a legal question, they absolutely need to know the AI isn't just making things up. RAG is the safety net that prevents false information and makes enterprise-grade AI actually possible. Let's move to Section 3, reducing system latency, engineering for speed. Okay, so now we know how to make it accurate, but here's the catch. Accuracy takes computational work, and work takes time. A perfect answer isn't very helpful if it takes 3 minutes to generate, right? We need these systems to be incredibly fast. To pull that off, developers utilize a few primary technical strategies to dramatically cut down on computation time. We're going to look at 4 key methods: caching, embedding quantization, selective query rewriting, and selective re-ranking. Each one plays a super specific role in making the system run leaner and faster. Let's start with the easiest, most straightforward first line of defense, caching. Caching is simply storing retrieved results or previously generated responses. Say user A asks a question. The system does the hard work of retrieving and generating. If user B comes along and asks the exact same question 5 minutes later, there is absolutely no reason the system should have to do all that heavy lifting again. It just pulls the answer right from the cache. It completely avoids redundant computation, which means the response time drops to basically zero. Next up is a slightly more technical but incredibly effective strategy: embedding quantization. When an AI searches external knowledge, it uses these complex mathematical representations called embeddings. Quantization is basically the process of lowering the bit precision of those numbers. Think of it kind of like compressing a giant high-resolution photo so it loads faster on a web page, but doing it with data. By lowering the bit precision, you drastically reduce the memory and computational load required. This significantly speeds up the entire retrieval phase, and the best part, you don't even lose the core meaning of the data. Now, let's see how all of this builds into an intelligent routing system. Because the truth is, you don't always need every heavy-duty tool in the toolbox. For simple queries, the system relies on those foundational speed strategies we just covered: caching and quantization. But what happens if a user types in a really complex or maybe highly ambiguous query? That is when the system dynamically routes the request to use more advanced strategies. Things like query rewriting, which actively refines the prompt prior to retrieval to get much better results. Or re-ranking, which carefully sorts the retrieved documents to find the absolute best context before generating an answer. The magic word here is selective. Both query rewriting and re-ranking are computationally heavy. They take real time. By only deploying them selectively, meaning we reserve them strictly for the complicated queries, developers cut down on completely unnecessary computation for the simple ones. Efficiency in a RAG system isn't just about throwing more and more processing power at the problem. It's about being incredibly smart with the power you already have. It's knowing exactly when to sprint and when to buckle down and do the heavy lifting. Which leaves us with a pretty fascinating thought to wrap up our explainer today. If Retrieval-Augmented Generation has fundamentally solved the accuracy problem by curing hallucinations, and smart selective routing is solving the latency problem by keeping these systems lightning fast, what new limits will developers push in next-generation AI architectures? We now have an AI foundation that is fact-based, reliable, and instantaneous. The bedrock is laid, so what incredible tools are we going to construct on top of it next? I hope this explainer gave you a crystal clear understanding of exactly how RAG works and why it matters so much to the future of AI. Keep exploring, keep learning, and I'll catch you in the next one.